In our previous video, we taught you how to determine if a relation is a function or not. Now, we also evaluated a particular function at various values. We had x equals to 2. We evaluated the function at x equals to a plus h, and we introduced the difference quotient formula. So in this video, we are going to be continuing the example problems we started in part 1. So pay keen attention and let's get it. Example number 4 says, given the function y equals the square root of x plus 2, evaluate f of 7. That's part A of the question. And part B says, solve f of x equals 4. Now, we told you in our past video that f of x is the same as y. So we say f of x equals to y. To evaluate part A of this question, you have to write y as f of x. So we say solution for A, we have, instead of y, we have f of x, because f of x is the same as y. So f of x is equals to the square root of x plus 2. Now we are told to evaluate f of 7. So to find f of 7, what will you have as the output value if you put 7 into the function as an input value? So anywhere to the right hand side you see an x, you replace it with 7. That's all. So f of 7 is equals to the square root of 7 plus 2. F of 7 is the square root of 7 plus 2, that's 9. So f of 7 will be the square root of 9 is 3. Now let's do the next example. 4b says we should solve the equation f of x equals 4. So we put b right here. We write f of x is equals to the square root of x plus 2. Great. So to solve f of x equal to 4, all we need to do is to replace f of x with 4 and solve for x. So f of x now is 4. So 4 is equals to the square root of x plus 2. Now, in this case, to solve this equation, you first have to get rid of the square root. In other words, you have to annihilate the square root. So to annihilate the square root, we square both sides. That's the common thing we say. So 4 equals to the square root of x plus 2. We square this side, and then we square this side. So 4 squared is 16. 16 is equals to, the square always cancel out the square root, because the square root is half, and this square is 2. Half times 2 is just 1. So we just have x plus 2 raised to the power of 1. Now to solve for x is to send this 2 across. So 16 minus 2 equal to x, which implies that x is equals to 14. So the solution to the equation f of x equals to 4 is x equals to 14. Now let's move on to example number 5. Example number 5 reads,
does the equation x squared plus y squared equals 1 represent a function with x as input and y as output?
If so, express the relation as a function y equals f of x.
So to determine as to whether this equation represents a function, the first thing we need to do is to solve for y. So we have solution x squared plus y squared equals to 1. Great. To solve for y is to send x squared across. So this y squared remains, y squared equals to 1. This x squared goes across, it becomes negative 1 minus x squared. So if you have y squared equals to 1 minus x squared, to solve for y is to take the square root on both sides. Simple as it is. So let's take the square root on both sides. We have the square root of y squared is equal to the square root of this entire stuff. Now, this square is going to cancel out the square root. Simple as it is, right? So y will be equals to, now once you take the square root of a particular quantity, if the quantity is not restricted to only positive values, right? If you take the square root of a particular quantity, we say that the quantity becomes plus or minus. Because if you square a positive number, you have a positive number. And if you square a negative number, you also have a positive number. So y is equals to plus or minus the square root of 1 minus x squared. If we solve this equation, we have this. Now, remember, we said for a relation to be a function, there should be a single x for each y. In other words, the x values must not repeat. Since we have plus or minus, it means y is equals to the square root of 1 minus x squared is one of the functions, and y is equals to minus the square root of 1 minus x squared is another function. That means if we replace x with 3, for example, in this function, we have two different values. We have a positive value and we also have a negative value. So for a single x, example 3, you have two different values of y. So because a single x gives you two values for y, we say that this particular relation, this equation, does not represent a function. Let's look at example number 6. Example number 6 says, from the table, that means this table, evaluate g of 3 and also solve the equation g of n equals to 6. So the first thing we will want to do is to evaluate g of 3, right? Remember, if you have g of a particular number, this number inside the parentheses is what we refer to as the input value, right? It is the first value, the input value. And g of that particular result, the entire thing, is the output value. So the first thing we have to do is to look at this table and then locate n. N in this case is 3. So you have n, you have g of n. N is 3 here. So let's locate what we have. N equals 3. N equals 3. This n equals 1. N equals 2. And this n equals 3. So for n equals 3, what is the value of g of n? So in this case, if n is 3, g of n, which is g of 3, will be 7. Therefore, g of 3 equals to 7. For this one, you don't have to solve, right? It's very easy. G of 5 is 8. Meaning, if you take this function g of n and you place 5 for n, you have 8, which is the output value. G of 1 is 8, g of 2 is 6, and so on. Now the next question says that we should solve g of n equals to 6. So this means that g of what number in this table gives us 6. And to answer that question, we look for the numbers n whose functional value g of n is 6. So let's see. And when n is equal to 1, g of 1 is 8. So n cannot be 1. Remember, we want to find n. N cannot be 1. When n is 2, g of 2 is 6, right? So since g of 2 is 6, it means one of the value of n is 2. So let's write that g of 2 is 6. G of 3 is 7. So we are not looking for 7, so 3 is not the answer. G of 4 is also 6. So g of 4 is equal to 6. And then g of 5 is 8. So we have two values of n for which g of n equals to 6. So to solve this, we just say n is equals to 2 n 4. So you can say n equal 2 n equal 4. Now, this particular relation is a function because remember the input values do not repeat. The input values do not repeat. Now, the output values here repeat. So you have 8 here, you have 8 there, you have 6, you have 6. And we said that to determine whether a particular relation is a function, you are not concerned about the output value, but you are actually concerned about what? There you go, the input value. This brings us to our next topic that we are about to discuss, which is a continuation of part 1 of this series. So we are done with evaluating examples like this. We are now going to determining if the graph of a particular relation represents the graph of a function, and to determine whether a function is a one-to-one function or not. So the next video is going to discuss that. Stay connected and do not forget to subscribe to our YouTube channel. Bye.